In this video, we will see further problems from exercise 3.1. So question number 9 says, if secant theta plus tan theta is equal to P, obtain the value of secant theta, tan theta and sin theta in terms of P. So you're given secant theta plus tan theta is equal to P. You need to find the values of secant theta, tan theta and sin theta in terms of P. So we know the formula that secant squared theta minus tan squared theta is equal to 1. This is one of the identities. So using this identity, we're going to derive that secant theta minus tan theta is equal to 1 by P and secant theta plus tan theta is equal to 1 by P, and thereby using these two equations we'll be able to find the value of secant theta separately and tan theta, and our sin theta is nothing but tan by secant theta. So from these two values we have to substitute. So this is the method that we will be following. So given secant theta plus tan theta is equal to P. Now we know that secant squared theta minus tan squared theta is equal to 1. This is in the form of a squared minus b squared. So we can expand it further as a plus b into a minus b. Secant theta plus tan theta into secant theta minus tan theta is equal to 1. Now we know that secant theta plus tan theta is equal to P. So substituting that here, you get P into secant theta minus tan theta is equal to 1. So further this can be secant theta minus tan theta is equal to 1 by P. Let's call this as 1 and this as 2. So if you're going to add 1 and 2, 1 plus 2, you get secant theta plus tan theta on the left hand side, and putting the left hand side of 2, you get plus secant theta minus tan theta is equal to P plus 1 by P. Here we can cancel out the tan theta and minus tan theta, so you get 2 secant theta is equal to P, if you take P as the common denominator, so it's P squared plus 1. So further simplifying, you get secant theta is equal to P squared plus 1 divided by 2P. So now we found the expression of secant theta in terms of P. So we can mark this as our 3. Then if you're going to subtract 1 minus 2, so let's do 1 minus 2. Then we get secant theta plus tan theta minus secant theta plus tan theta. So this is equal to our P on the right hand side, and here it is minus 1 by P. So further you can see that our secant theta and minus secant theta will get cancelled. So you're left with 2 tan theta is equal to, taking a common denominator P, P squared minus 1. This implies that our tan theta is equal to P squared minus 1 divided by 2P. So this can be our number 4. Next, we know sin theta is equal to tan theta divided by secant theta. So substituting the values of tan theta and secant theta, we get our tan theta is P squared minus 1 divided by 2P divided by our secant theta, which is P squared plus 1 divided by 2P, which is nothing but P squared minus 1 divided by 2p, and changing the division to multiplication here, this will become 2p by p squared plus 1. So your 2p and your 2p will get cancelled. So you are left with p squared minus 1 divided by p squared plus 1. So that is our sine theta. So your secant theta is equal to p squared plus 1 by 2p. Your tan theta is equal to p squared minus 1 by 2p, and your sine theta is equal to p squared minus 1 divided by p squared plus 1. That's the answer. Question number 10. If cot theta into 1 plus sine theta is equal to 4m and cot theta into 1 minus sine theta is equal to 4n, then prove that m squared minus n squared the whole square is equal to mn. So the method that we would follow is, first we will replace cot theta, which is here and here, as cos by sine theta. Then you will be able to bring out these expressions. 4m is equal to cot theta plus cos theta, and 4n is equal to cot theta minus cos theta from these two expressions. Then we will go here and we will substitute these values of m and n in the left hand side first, and then the right hand side, and then we will find they both come equal to 1 by 16 into cot square theta into cos square theta. So let's solve the problem. Our cot theta into 1 plus sine theta is equal to 4m. Therefore, we can say that cot theta plus cot theta sine theta is equal to 4m. Replacing cot theta here with cos theta by sine theta, you get cot theta plus cos theta by sine theta into sine theta is equal to 4m. Now sine theta will get cancelled here. So your 4m now is equal to cot theta plus cos theta. Therefore, your m is equal to cot theta plus cos theta divided by 4. Similarly, taking the second expression here, which is cot theta into 1 minus sine theta is equal to 4n. Further, multiplying it inside, you get cot theta minus cot theta sine theta is equal to 4n. And replacing this cot theta with cos theta by sine theta, you get cot theta minus cos theta by sine theta into sine theta is equal to 4n. Sine theta will get cancelled. So you're left with 4n is equal to cot theta minus cos theta. Therefore, your n is equal to cot theta minus cos theta divided by 4. Now let's take the right hand side first, or RHS first. So our RHS is m, n. So substitute the value of m and n into the right hand side. So this will be cot theta plus cos theta divided by 4 into n is cot theta minus cot theta minus cos theta divided by 4. Further, multiplying this is in the form of a plus b into a minus b. So 4 into 4 is 16, 1 by 16 into cot squared theta minus cos squared theta. So we're going to now substitute cot theta with cos theta by sine theta. So this, let me bring it here to create space. 1 by 16 into cos squared theta by sine squared theta minus cos squared theta. So that will be further equal to, taking sine squared theta as the denominator, you would have cos squared theta minus sin squared theta cos squared theta divided by sin squared theta. Okay. Now, cos squared theta is common to both, so we can take it out. Again, let me bring it here. So, 1 by 16 into, taking the cos squared theta as a common, 1 minus sin squared theta divided by sin squared theta. Now, cos squared theta divided by sin squared theta is nothing but cot squared theta, right? Cos by sin is cot. So, it is 1 by 16 into cot squared theta, and our 1 minus sin squared theta is cos squared theta. So, into cos squared theta. So, let's call this as 1. Now, let's go to the left hand side. So, before we go into the left hand side, let's first take n squared minus n squared. So, n squared minus n squared can be written as m plus n into m minus n. Okay, a squared minus b squared is equal to a plus b into a minus b. So, now let us substitute the values of m and n onto this. So, our m here is cot theta plus cos theta. Since 4 is a common denominator for both, we will keep the denominator as 4, and this will be plus cot theta minus cos theta. This multiplied by m minus n. So, m minus n will become cot theta plus cos theta minus cot theta, minus into minus plus, plus cos theta, the whole thing divided by 4, because 4 is common denominator for both. So, here cos theta and cos theta will get cancelled, and cot theta and cot theta gets cancelled here. So, you are left with 2 cot theta. So, 2 cot theta divided by 4 into 2 cos theta divided by 4. Again, this becomes 2, this becomes 2. So, you are left with 1 by 4 cot theta into cos theta. Therefore, our LHS, which is m squared minus n squared, the whole squared, which is here, is now equal. We found that m squared minus n squared is equal to 1 by 4 cot theta into cos theta. So, this will be 1 by 4 squared into cot squared theta cos squared theta, which is equal to 1 by 16 cot squared theta cos squared theta. So, this is 2. So, from 1 and 2, our LHS is equal to RHS, hence the proof. Question number 11. If cosec theta minus sin theta is equal to a cube and secant theta minus cos theta is equal to b cube, then prove that a squared b squared into a squared plus b squared within bracket is equal to 1. So, here what we would do is, we would have to rearrange these two expressions with sin theta and cos theta. So, you would end up having a cube as cos squared theta by sin theta and b cube as sin squared theta by cos theta. Then substitute then the values of a and b into this, then you will be able to prove it's equal to 1. So, let's start. So, we are given our a cube is equal to cosec theta minus sin theta. So, this can be rearranged as cosec theta is nothing but 1 by sin theta minus sin theta, which is equal to 1 minus sin squared theta divided by sin theta. Taking sin theta as a denominator common, Sine theta into sine theta will become sine squared theta. So which is equal to cos squared theta divided by sine theta. Similarly, our b cube is equal to secant theta minus cos theta. Therefore, this is equal to 1 by cos theta minus cos theta. Secant theta is 1 by cos theta. So further taking cos theta as the denominator, you get 1 minus cos squared theta, and 1 minus cos squared theta is sine squared theta. So it's sine squared theta divided by cos theta. So we can further, our A will be equal to cos squared theta by sine theta to the power 1 by 3, and our B will be equal to sine squared theta divided by cos theta to the power 1 by 3. So now let's first take the a squared minus b squared term. So a squared times b squared term. A squared times b squared is equal to, let's put these values here, cos squared theta by sine squared theta to the power, because it's a square, so 1 by 3 will become 2 by 3 times b is going to be sine squared theta divided by cos, this is cos sine theta, not sine squared theta. So by cos theta to the power, again it's a square, so our 1 by 3 will become 2 by 3. So this will become, because it's the same power 2 by 3, so we can take the power out. So let's call this as cos squared theta by sine theta, which is our A, into sine squared theta divided by cos theta to the whole power 2 by 3. Here our cos theta and the square term will disappear, and the sine theta and the square term will disappear. So you will be left with cos to the power 2 by 3 here, 2 by 3 theta into sine to the power 2 by 3 theta. Next, let's take our a squared plus b squared. So our a squared plus b squared will be equal to, so our a is cos squared theta by sine theta to the power 2 by 3 plus our b will be sine squared theta by cos theta to the power 2 by 3. Okay, now since the denominator is sine theta here to the power 2 by 3 and it's cos to the power 2 by 3 theta, so let's first actually move the power inside. So you will get this as cos to the power 4 by 3 theta divided by sine to the power 2 by 3 theta plus sine to the power 4 by 3 theta divided by cos to the power 2 by 3 theta. So we take sine 2 by 3 theta and cos 2 by 3 theta as our denominator, then this will become, so we have sine 2 by 3 theta into cos 2 by 3 theta, that's our denominator. So our numerator now will become cos to the power 4 by 3 theta into, the denominator here will be cross multiplied here, so it's cos to the power 2 by 3 theta plus sine to the power 4 by 3 theta into, this denominator will be cross multiplied here, sine to the power 2 by 3 theta. So further 4 by 3 power and the 2 by 3 power, you can add them together, then it will become 6 by 3. So this is equal to, and 6 by 3 is nothing but 2. So this will become cos squared theta. Similarly, this will become sin squared theta divided by sin to the power 2 by 3 theta into cos to the power 2 by 3 theta. Now we know that this term is equal to 1, cos square theta plus sin square theta. So this is equal to 1 by sin 2 by 3 theta into cos 2 by 3 theta. So if we call this as our 1 and this as our 2, then from 1 and 2 we can say a squared b squared into a squared plus b squared is equal to, from 1, a squared b squared is equal to cos 2 by 3 theta into sin 2 by 3 theta, and a squared plus b squared from 2 is 1 divided by sin to the power 2 by 3 theta into cos to the power 2 by 3 theta. They are the same, so you can cancel them. So your answer is 1. Therefore, LHS is equal to RHS. Question number 12. Eliminate theta from the equations a sin theta minus c tan theta is equal to b and b secant theta plus d tan theta is equal to c. So for this, what we would do is we would use x instead of secant theta and y instead of tan theta, and so it will become a linear equations, two linear equations. Then we can use the elimination method and solve this problem. So let's say let x equals secant theta, y equals tan theta. So your equation now becomes a x minus cy is equal to b and b x plus d y equals to c. So if I'm going to call this equation as 1 and this equation as 2, then let's multiply equation 1 with d. Then we get a dx plus, minus here, c dy is equal to b d, and let's call this as our equation 3. Similarly, let's multiply our equation 2 with c. Then you get bcx plus cdy is equal to c squared. So let this be 4. Now if we do 3 plus 4, we would get, so this and this will get cancelled. So you will be left with a dx plus bcx is equal to bd plus c squared. So we can take x common. So x into ad plus bc is equal to bd plus c squared, which implies your x is equal to now bd plus c squared divided by ad plus bc. And we know that x is equal to secant theta. Therefore, secant theta is equal to bd plus c squared divided by ad plus bc. Similarly, let's multiply 1 with b. So our 1 with b will now become, this is our 1. If you multiply with b, it will become abx minus bcy is equal to b squared. And let's multiply 2 with a. So our 2 will now become abx plus ady is equal to ac. Now if we take this as 3, this is as 5 and this as 6, and if we do 5 minus 6, then you would get, since our, so it's a minus here, so you would get this as these two terms disappear. So minus bcy minus ady is equal to b squared minus ac. So further simplifying this, taking the y common, you will be left with, we'll take the minus y out, so it will be bc plus ad is equal to b squared minus ac. So further our y will now become b squared minus ac divided by minus of bc plus ad. So eliminating the minus, we can say this is ac minus b squared divided by bc plus ad. So our y is nothing but tan theta. Therefore tan theta is equal to ac minus b squared divided by bc plus ad. Now we know that secant squared theta minus tan squared theta is equal to 1. So let's apply the values of our secant theta and tan theta that we got into this. So this becomes bd plus c squared divided by, denominator is ad plus bc squared, minus for tan theta it is ac minus b squared, the whole squared, here's whole squared, divided by bc plus ad, the whole squared, and this is equal to 1. Now you can see the denominator, they are the same, therefore we can write this as ad plus bc the whole squared, and in the numerator we have bd plus c squared the whole squared minus ac minus b squared the whole squared is equal to 1. So further taking this to the other side, you can rewrite this as bd plus c squared the whole squared minus ac minus b squared the whole squared is equal to ad plus bc the whole squared. So we can further rearrange this by taking it to the other side. This is bd plus c squared the whole squared is equal to ac minus b squared the whole squared plus ad plus bc the whole squared. That's the required answer. Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.